All right, any questions on this example? Because now we're going to see another method. Okay. So now the next method that we are going to see, as you can see from the title, is the elimination method. And it's really what it sounds like. It's another way to get to eliminate a variable. I mean, with substitution, right, we did a bunch of steps, but it really boiled down to getting one variable in terms of the other. And using that, you eliminated a variable. Here, we're going to eliminate a variable. We're really not going to get one variable, though, in terms of the other. What you basically are going to do is, as indicated here, essentially, you're going to multiply the equations by numbers to adjust coefficients so that when you add the equations, a variable goes away. We'll see some examples of that. But you might multiply both equations by something so that the coefficients of x, for instance, if you were to add them, x would vanish. So they would be the same, except they would be opposite in sign, like 2 and -2, 4 and -4, for instance. You'll see what I mean when we do some examples. And you can eliminate x, or you can eliminate y, of course. What will happen is you will get an equation in one variable. Just like with substitution, right? We essentially got one equation in one variable only. And that's what we're going to do here as well. And once you've got one equation in one variable, you solve it, then you back substitute. Basically, you substitute kind of like what we did with substitution. You substitute and then get the other variable. That is, you substitute into one of the original equations. And then write your solution as an ordered pair. You always want to write it as an ordered pair. Or if there's infinitely many, you say so. What the book does, let me say this, if there's infinitely many solutions, they present the solutions in a form, in set form. I'm not going to worry about that, though. Okay. You could just write, for me, in other words, infinitely many solutions. So, if we were in class, I might be a little more strict. But again, because of this online, situation, so to say, I'm not going to get too strict like that. And of course, you check your results. It's good to do that. All right. Okay, let's dive in and do some examples. So for instance, let's say we want to solve this. Okay, now what we can do is somehow we want to add these equations. We want to be able to add them and eliminate x or y. Now looking at the system, it looks like we can't do that, right? Because the coefficients won't cancel if you add them. But if you were to multiply the first equation by 4, let's say, the coefficient of x would be 8, right? That's what's happening here. And if I multiplied the second equation by 3, sorry, not x, I meant y, my mistake. So if we're going to multiply the first equation by 4 and the second equation by 3, right? What's going to happen? Well, we get 8x plus 12y equals 84. For the second equation, we get 9x minus 12y is 69. Okay, now how did that help us? Well, notice we have this new system here, right? We want to be able to add the equations so that when we add them, a variable cancels. Doing this, we can see that the y's are going to cancel, and that's what I'm doing here. We add them. I mean, sometimes, you have to look and be like, oh, well, if this were instead 12 and this were instead 12, or like sorry. If we multiply the first equation here, we have a 3. Well, if we multiply it by 4, and this one we multiply by 3, then both of these would be 12 and negative 12, and we could add and combine them, which would eliminate them. And that's what we're doing here. Right? The whole idea is you want to eliminate a variable. So if we add these, what's going to happen? Well, the y's go away. Here we get 17x. Here, if you add these, you get 153. Okay, sometimes you may have to play around a bit. You know, sometimes you could just look at these and be like, oh, well, this is 3 and this is negative 4. Well, if I multiply this by 4 and this by 3, which is what I did, both of these would be, this would be 12, this would be minus 12. We can add them and they vanish, and the y would be gone. So now we only have x to deal with. So we have 17x is 153. So we can solve that. We have one equation, one unknown, right? And we easily get x. You just divide by 17. When you do so, you get x is 9, as we can see. Now, are we done once we know x? Well, as you can see from here, no, we're not done, right? And why are we not done? Well, we need y. But really the hard part is done, because once we know one variable, we can easily get the other. We can use either equation in the original system. So what I decided to use was the first equation. We know x is 9, so I substitute. And you know, through some algebra, we solve to get y. So we have x is 9, we plug it in, we get 18 plus 3y is 21, right? That was the first original equation. Okay, these cancel. Well, this cancels, excuse me. We get 3y is 3. Divide both sides by 3, we get y equals 1. So the only solution is 9, 1. 9, 1, this ordered pair. But this illustrated the method of elimination. We want to eliminate a variable somehow, okay? And we noticed that if we multiplied the first equation by 4, the second one by 3, the coefficient of y here is 12. The coefficient of y in this equation is negative 12. So we know that if we added the equations, the y here would cancel, right? The coefficients are opposite in sign. Okay. So that's what we did here. Now, is that the only method you can use here? No, of course not. Here, I'm going to show you another thing you can do. Still elimination, right? What else can we do? Well, looking at x now, if I multiply the first equation by 3 and the second equation here by negative 2, right? Is that going to help us? Well, if I multiply the first equation by 3, we have 6x plus 9y equals 63. For the second equation, right, if I multiply by negative 2, we have negative 6x down here, 8y plus 8y equals negative 46. By doing this, we can see that if we were to add, we can see now that the coefficients of x in our new system, they're the same except they're opposite in sign, 6 and negative 6. So if we were to add these, x would vanish. The x variable would be gone. And that's what we can do. So we have 9y plus 8y here is 17y. If you add these, you just get 17. And the x is gone. Okay, so again, we have 17y is 17, but we want y. That's easy. You just divide by 17. We get y is 1. Then, just like the other one, right? just like the other one, previous example, we replace the value for the variable in either equation. So I'm using the first one again, but you could use the second if you want. We know what y is. We substitute y in. What do we do next? We get x, the other variable. When I plug this in, right, you can see that y becomes 1, so we get 2x plus 3 is 21. So we have 2x plus 3 is 21. And now we just solve for x, right? We subtract 3 from each side. We get 2x equals 18. Divide both sides by 2. We get x equals 9. So again, we get 9, 1. Thank goodness. Okay. So again, what it boils down to in elimination is, you have to look at the equations a bit and say, if we add these, will a variable go away? Looking at this system at first, well, no, it's not going to go away if we just add these directly. But looking at either variable, in the first case, we looked at y. In this case, we looked at x and said, well, if somehow if we multiply the first one by 3 and the second one by 2, right? The first one would become 6x. This would become negative 6x. Well, in that case, if we added, they would cancel. And that's what we did. We multiplied the first equation by 3. The second equation we multiplied by negative 2. Now they're just opposite in sign. But if we add these, they would vanish. Okay. Let's do another one, but let me just pause the recording.